Hello everyone, myself Krishna from Shri Venkateshwara College of Engineering, studying 4th and CSE. Today I am here to explain about graph theory. So let's come to the introduction. So graph theory was first introduced by Swiss mathematician Euler in 1736, and the field continued to develop throughout in the 19th and 20th centuries with notable contribution from mathematicians. So what's graph theory? In mathematics, graph theory is the study of graphs which are mathematical structure used to model pairwise relation between the objects. Graph in this context is made up of vertices, also called as nodes or points, which are connected by edges. They are also called as links or lines. A distinction is made between undirected graphs where edges link two vertices symmetrically and directed graphs where edges link two vertices asymmetrically. Graphs are one of the principal objects to study in discrete mathematics. So let's know the importance of graph theory. Graph theory has application far beyond the world of the discrete mathematics. For instance, much of the computer science operations through the usage of graph algorithms and data structures. Chains of code operate like the vertices and edges of a graph. As the user interacts with software, they engage in a form of graph traversal. Business people, economists, financial professionals also use graphs to depict data points. Although the graph for such circumstances might be simpler than those in use by mathematicians in the advanced graph theory, they still operate off the same basic principle. By using insight from the graph theory, professionals in these fields can achieve optimization for their own business models. So, what is a graph? A graph is a non-linear data structure consisting of vertices and edges. The vertices are sometimes also referred to as nodes, and the edges are lines or arcs that connect any two nodes in the graph. More formally, a graph is composed of a set of vertices V and a set of edges E. So the graph is denoted as G of E, V. So what are the components present in the graph? Vertices. Vertices are fundamental unit of a graph. Sometimes vertices are also known as vertex or nodes. Every vertex or nodes can be labeled or not. Edges. Edges are drawn or used to connect two nodes of the graph. It can be ordered pair of nodes in a directed graph. Edges can connect any two nodes in any possible way. There are no rules. Sometimes edges are also known as arcs. Every edge can be labeled or not. So the basic concept of a graph. A graph is a mathematical structure consisting of a set of points called vertices and set of lines linking some pair of vertices. It is possible for the edges to orientate, that is to be typed edges. The lines are also called as edges if they are undirected and or arcs if they are directed. So what is loop and multiple edges? In a loop is an edge that connects the vertices to itself. If the graph has more than one edge joining some pair of vertices, then these edges are called as multiple graph. Simple graph. A simple graph is a graph that doesn't have one or more edges between any two vertices, and no edges starts and ends at the same vertex. In other words, a simple graph is a graph without loop and multiple edges. So what is adjacent graph? Two vertices are said to be adjacent if there is an edge or arc connecting them. Adjacent edge. Adjacent edge are the edges that share a common vertex. Degree of vertex. The degree of vertex is the number of edges incident with the vertex. Path. A path is a sequence of vertex with the property that each vertex in the sequence is adjacent to the vertex next to it. A path does not repeat vertices is called a simple path. A cycle. A circuit that doesn't repeat vertices is called a cycle. Connected graph. A graph is said to be connected if any two of its vertices are joined by a path. A graph that is not connected is a disconnected graph. A disconnected graph is made up of connected subgraphs that are called components. Bridges. A bridges is an edge whose deletion from the graph increases the number of components in the graph. If a graph was connected graph, then the removal of the bridge edge disconnects it. So the types of graphs are directed and undirected. In directed graph, there will be arrows which direct, and in undirected graph, there will be no arrows. So in directed graph, the edges direct the path that must be taken to travel between the connected nodes. The edges are typically represented as arrows. In undirected graph, do not show any direction which must be taken between nodes. Instead, travel between the nodes is allowed along an edge in either direction. There are no loops or multiple edges in undirected graph. So graph representation, it can be represented in adjacency matrix or adjacency list. An adjacency matrix is a compact way to represent the structure of a finite graph. If a graph has n vertex, its adjacency matrix is an n into n times an n into n matrix, where each entry represents the number of edges from one vertex to another. Adjacency list. An adjacency list represents a graph as an array of linked lists. The index of the array represents a vertex, and each element in its linked list represents the other vertex that form an edge with a vertex. So, how is graph application used in computer science engineering? So, we use graph application in data structures. That is, graphs are fundamentally data structure used to represent various relationships and dependencies. These are specific type of graph that are used in many algorithms and data storage structures. Network analysis. In computer networks, graph theory helps analyze connectivity, find bottlenecks, and optimize data transmission. Algorithm. Many algorithm like Wittstars algorithm finding the shortest path, Driscoll's algorithm for finding the minimum spanning tree, and based on the graph theory concept. Social networks. Social media platforms use graph theory to model and analyze user connection, enabling brand recommendation and target advertising. So, how is graph theory used in transportation? It is used in route optimization, traffic engineering, supply chain management. So, what's route optimization? Graph theory is used to find the most efficient routes for the transportation, whether for delivery trucks, public transit, or airline routes. So, what's traffic engineering? Transportation engineers use graphs to model roads network, analyze traffic flow, and optimize signal timings. Supply chain management. Graphs help model complex supply chain network allowing for efficient production and distribution. Howard graph used in biology for genetic interaction networks. Graph represent relation between the genes and the proteins in the biological system, helping biologists understand complex interaction. And phylogenetics. Phylogenetically, a type of graph depicts the evolutionary relationship between the species. Epidemiology. Graph theory is used to model the spread of diseases in population. Social networking. So, social network analysis. Graph theory is used to study the social network, friendship, collaboration, and influence progression in various social networks. Opinion dynamics. It helps analyze how opinions and behavior spread within the society. Linguistics and natural language processing. Semantic networks. Graphs are used to represent relationship between the words or concepts, aiding in natural language understanding and machine translation. Document similarity. Text document can be represented as graph, making it easier to compare the content. So, how is graph theory used in chemistry and material science? So, in chemical components, structures are often represented as molecular graph, helping chemists understand molecular properties and reactions. Material science graph theory helps model and analyze the structure and properties of the material, such as crystal lattice. So, recommendation systems collaborative filtering. Recommender system use graph to model user item interaction and suggest product, movies, or music based on similar preference. Electrical engineering, circuit analysis. Electrical circuits can be represented as electrical networks where graph theory techniques are used to analyze voltage, current, and power flow. Urban planning, that is city planning. Graphs model urban infrastructure such as road network, public transportation systems, and utility grids, facilitating efficiency, city planning, and maintenance. These are just few examples, and graph theory has been application in many other domains, including finance, psychology, and environmental science. It's versatile in modeling complex relationships, makes it a valuable tool in various fields. Thank you.